At 5:09 in the morning, the ground in Wyoming ripped itself open. A fissure, 60 feet long, fractured the earth. It happened on June 13th, 2026. A blast of superheated water and rock exploded from the ground in Biscuit Basin, throwing boulders into the morning air. A new boiling pool fumed into existence where solid ground had been just moments before. The United States Geological Survey recorded everything. Another hydrothermal explosion. The second major blast in this exact area in just 2 years. 57 miles south of that fissure sits Jackson, Wyoming, a town of impossible wealth, surrounded by impossible beauty, nestled at the foot of the Teton Mountains. Billion-dollar homes, private jets. A playground for people who believe they are insulated from consequence. They live 1 hour and 15 minutes away from a geologic event that no amount of money can stop. They are living on the doorstep of a power that does not negotiate. What do you think is the real danger at Yellowstone? The slow-burning supervolcano, or the sudden steam blasts happening right now? Tell me in the comments below. The explosion in June was a tremor, a warning shot, a reminder that the real show is still waiting in the wings. Because beneath the geysers and the hot springs, beneath the tourists and the park rangers, lies a magma chamber so vast it defies comprehension. A supervolcano that has torn the continent apart 3 times before. And the people in Jackson are living in the shadow of the fourth. A shockingly high number of people who watch these documentaries aren't subscribed. If you value this kind of in-depth analysis, do me a favor and hit that subscribe button right now so you don't miss what's coming next. It is a small click that makes a monumental difference for us. Let's begin. Yellowstone is not a mountain. It's a hole, a gigantic sunken crater, a caldera, so large you can't see its edges from the ground. 45 miles wide, 85 miles long. It was formed by an eruption 631,000 years ago, an event so violent it ejected 1,000 cubic kilometers of rock, ash, and magma, enough material to bury the entire state of Texas under 5 feet of debris. That was the Lava Creek eruption, and it wasn't even the biggest. 2.1 million years ago, the Huckleberry Ridge eruption exploded with more than double that power. 2,450 cubic kilometers of the North American continent were vaporized and thrown into the atmosphere, creating the Island Park caldera. The ash from that single event has been found as far away as California, Missouri, and southern Canada. It was an extinction-level event, a planetary catastrophe that originated from the exact same spot in northwestern Wyoming. And it wasn't the last one. Another blast, the Mesa Falls eruption, tore a new caldera into the earth 1.3 million years ago. A smaller, but still cataclysmic event. 3 supereruptions, 3 continental-scale disasters, all from the same geologic engine. A stationary mantle plume, a hotspot, burning a hole through the Earth's crust as the North American plate inches slowly southwest over it. This is the cycle. This is the history written into the bedrock. So when scientists look at the ground in Yellowstone, they don't see a park, they see a crime scene. A place where the planet has demonstrated, repeatedly, its capacity for unimaginable violence. The question everyone asks is simple. When will it happen again? For decades, a terrifyingly simple piece of math has fueled doomsday headlines. The time between the first and second eruption was about 800,000 years. The time between the second and third was about 669,000 years. An average of roughly 730,000 years between supereruptions. And since the last one was 631,000 years ago, the conclusion seems obvious. The clock is ticking. The system is overdue. It is a neat, terrifying, and completely wrong idea. Volcanoes do not run on a schedule. They are not waiting for an alarm clock to go off. They erupt based on physics, not calendars. The conditions inside the magma chamber have to be perfect. The heat, the pressure, the volume of liquid melt. And right now, the math that actually matters says an eruption is not just unlikely. It is physically impossible. For years, the image of Yellowstone's magma chamber was a myth, a Hollywood invention, a vast, hollow cavern filled with a sloshing lake of molten lava, just waiting for a crack to form. The reality is far less cinematic and far more complex. The chamber is not a pool of liquid. It's what geologists call a magmatic mush, a sponge. A colossal, semi-solid body of hot rock, crystals, and superheated gases with pockets of liquid magma trapped inside the crystalline matrix. It is mostly solid. The critical question is, how much of it is liquid? An eruption can only happen when there is enough connected melt to mobilize, to gather, and to force its way to the surface. For a supereruption to occur, scientists estimate that the magma chamber needs to reach a critical threshold of 35% to 50% liquid melt. Below that, it's just a hot, angry sponge. Above that, it's a loaded gun. For a long time, the best estimates put Yellowstone's melt percentage somewhere between 5 and 15%. Active, but stable. Hot, but not ready. Then came the study that made everyone sit up straight. In December of 22, a paper published in the journal Science completely changed the calculation. Using advanced seismic imaging, a technique that works like a planetary scale ultrasound, scientists were able to create the most detailed map of the magma chamber ever produced. Their findings were unambiguous. The shallow magma reservoir beneath Yellowstone contains between 16 and 20% liquid melt. Suddenly, the number was higher, considerably higher than anyone had thought. The headlines wrote themselves. But the scientists who produced the data urged caution. 16 to 20% is not 35. It is not 50. The volcano is hotter than we knew, but it is still not hot enough. Not even close. The system is not capable of producing a supereruption today. The physics simply isn't there. So if the great beast is still sleeping, what was that explosion in Biscuit Basin on June 13th? What was the blast in the same spot in July of 2024 that destroyed a tourist boardwalk? What are the thousands of earthquakes that shudder through the park every single year? In June of 2026 alone, the University of Utah seismograph stations located 118 separate quakes. Is an hour-and-a-half drive enough of a buffer? If you had a 72-hour warning, is there anywhere you could even go? Let me know your plan in the comments. I'm genuinely curious what people would do. This brings us to the uncomfortable truth of Yellowstone. The truth that Michael Poland, the scientist in charge of the Yellowstone Volcano Observatory, has been trying to get the public to understand for years. Everyone is staring at the wrong monster. When we look at Yellowstone geologic hazards, Poland says, I think most people tend to immediately think about a supervolcano, which is a term I absolutely hate. The real hazards on human timescales in that area are big tectonic earthquakes and these steam explosions. The real danger is not magma, it's water. Yellowstone sits on top of one of the most complex and volatile hydrothermal systems on the planet. A labyrinth of cracks and fissures allows rainwater and snowmelt to percolate deep into the Earth's crust, where it comes into contact with the searing heat radiating from the magma chamber below. The water is superheated to hundreds of degrees Celsius, far beyond its boiling point, but kept in a liquid state by the immense pressure of the rock above it. It becomes a geologic time bomb. A hydrothermal explosion happens when that pressure is suddenly released. A shift in the ground, a small earthquake, or a change in the underground plumbing can cause that superheated water to flash instantly into steam. When water becomes steam, it expands to more than 1,500 times its original volume. That expansion is not a gentle process. It is an explosion. It shatters the overlying rock, hurling it hundreds of feet into the air, carving out new craters in a matter of seconds. These are not small events. The explosion in Biscuit Basin in 2024 was powerful enough to destroy a reinforced section of boardwalk. The one in 2026 opened a 60-foot crack in the earth. And these are just the most recent examples. Yellowstone's history is pockmarked with craters from hydrothermal blasts far larger than anything seen in modern times. Some are more than a mile across. An explosion of that scale today wouldn't just close a boardwalk. It would obliterate a huge section of the park, instantly killing anyone within miles. This is the hazard that happens without warning. There are no long-term precursors, no swelling ground or escalating earthquake swarms that signal a coming eruption for months or years. a hydrothermal explosion can just happen tomorrow morning. Now, this is why, as of July 4th, 2026, the USGS is racing to install new monitoring equipment across the park. Not to watch for a supereruption, but to try and get a handle on the wildly unpredictable behavior of its steam and water. They are tracking a threat that operates on the scale of minutes, not millennia. The residents of Jackson, just 57 miles away, live with this geologic reality every day. Their town is built on the edge of a system that is constantly moving, constantly breathing. The entire Yellowstone caldera floor is rising and falling in a slow, rhythmic cycle. Since 2015, the ground has been subsiding, sinking at a rate of about 1 inch per year. Not from magma draining away, but from subtle shifts in the vast hydrothermal and groundwater systems beneath the surface. It is a sign of a living, breathing, and fundamentally unstable place. If you're finding this analysis valuable, take 1 second and hit the like button. Then share this with someone you know who lives near something they take for granted. It helps spread the word more than you know. But what about the other threat Michael Pollan mentioned? The one that gets lost in the noise about magma. A big tectonic earthquake. Yellowstone sits at the intersection of major fault lines in the intermountain seismic belt. The forces of the Earth's crust being stretched apart are constantly building up stress. In 1959, that stress was released. The Hebgen Lake earthquake, a magnitude 7. 3 quake, struck just west of the park boundary. It was not a volcanic event. It was a purely tectonic earthquake. And it was catastrophic. The shaking was so violent it triggered a massive landslide. 80 million tons of rock broke loose from the side of a mountain and crashed into the Madison River Canyon at over 100 miles per hour. The slide created a wind blast so powerful it threw cars into the air. It buried a campground, killing 28 people in their sleep. It dammed the river instantly, creating a new lake, now known as Quake Lake, that submerged miles of highway. The quake changed the plumbing of Yellowstone itself. Geysers that had been dormant for years roared to life. Old Faithful's eruption intervals changed permanently. The ground throughout the park deformed by as much as 20 feet. It was a stark reminder that the ground here doesn't need magma to create a disaster. The rock itself is broken. A 7.3 magnitude earthquake centered closer to Jackson today would not just rattle the town, it would shatter it. So you have two very real, very present dangers. Steam explosions that can happen without warning, and massive earthquakes that can strike at any time. Either one would be a regional catastrophe. And still, they are not the main event. They are not the reason Yellowstone holds a unique place in our nightmares. Because for all the scientific certainty that a supereruption is not imminent, there is another, more chilling certainty. If it ever does happen, none of this other stuff will matter. Let's imagine the impossible. Let's say that, against all odds, the models are wrong. Let's say that over the next century, the conditions change. The magma chamber's melt percentage begins to climb. 16% becomes 20. 20 becomes 25. The system starts to wake up. The ground swells not by inches, but by feet. The Earth screams with thousands of earthquakes every day. The scientists at the YEVO issue the most terrifying warning in human history. Yellowstone is going to erupt. What happens next? The end does not begin with fire. It begins with ash. The eruption would not be a single blast, but a sustained, cataclysmic event lasting for days or weeks. A column of superheated gas and pulverized rock would be fired more than 25 miles into the stratosphere. The sheer volume of material ejected would be so immense that the eruption column would collapse under its own weight, sending supersonic waves of destruction tearing across the landscape in every direction. These are pyroclastic flows, currents of gas and volcanic matter heated to over 800 degrees Celsius, moving at hundreds of miles per hour. They are unsurvivable. Anything within a 100-mile radius of the caldera would be incinerated and buried instantly. Jackson, Wyoming, 57 miles away, would cease to exist in minutes. The cars on its streets, the paintings in its galleries, the people in its billion-dollar homes. Gone, obliterated, scoured from the face of the earth. But the pyroclastic flows are only the beginning of the disaster. They are the local catastrophe. The global one comes from the ash. Millions of tons of fine volcanic ash would be injected into the upper atmosphere, forming a colossal umbrella cloud that would spread out and blot out the sun. This is where the truly terrifying physics begins. And it comes from a study published on August 27, 2014, by a team of USGS scientists led by Larry Maston and Jacob Lowenstern. They created a computer model called Ash 3D to simulate what would actually happen to the ash from a Yellowstone supereruption. For years, the assumption was simple. The prevailing westerly winds, the jet stream, would carry the ash eastward, burying the Midwest and the East Coast, while largely sparing the West. The Ash 3D model proved this assumption was dangerously wrong. Larry Maston explained their findings with chilling clarity. In essence, the eruption makes its own winds that can overcome the prevailing westerlies, which normally dominate weather patterns in the United States. The umbrella cloud would become so massive, so powerful, that its outer edges would expand radially, pushing ash over 1,000 kilometers in every direction, including west. Directly against the jet stream, the model showed what history had hinted at. This helps explain the distribution from large Yellowstone eruptions of the past, Maston noted, where considerable amounts of ash reached the West Coast. The consequences are almost unthinkable. Cities like Portland, Seattle, and Vancouver, which thought they were safe, would be buried. Boise would get 3 feet of ash. Salt Lake City, a meter. Denver would be plunged into darkness. The ash is not like fireplace soot. It's pulverized rock and glass. It is heavy, abrasive, and when wet, it turns into a concrete-like slurry. A few millimeters can shut down airports. A few inches can collapse rooftops. A few feet in Jackson would make the town an uninhabitable, monochromatic moonscape. The ash would clog every river, contaminate every water supply, and smother every farm field across half the continent. The entire agricultural heartland of the United States would be rendered barren for a decade. Global air travel would stop, and the sheer volume of sulfur dioxide and other gases injected into the stratosphere would trigger a volcanic winter, causing global temperatures to plummet for years. It would be a catastrophe on a scale human civilization has never witnessed. This is the true nature of the threat. It's not just an eruption. It's a fundamental rewriting of the planet's climate and geography. And it is a future that is not impossible, only improbable on human timescales. All right, a quick pause. I know I keep bringing this up, but it's genuinely important. The vast majority of you watching right now are not subscribed. If you've been fascinated by this journey into Yellowstone's geology, please take a moment and click that subscribe button. It's the single best way to support this channel and ensure we can keep making deep dives like this one. Thank you. Now, back to the science. The scientists at the Yellowstone Volcano Observatory live with this knowledge every day. They are the sentinels on the wall. Michael Poland and his team operate one of the most sophisticated volcanic monitoring networks on Earth. A web of GPS stations, seismometers, gas sensors, and satellite systems watches every breath the volcano takes. The ground deformation, the number and location of earthquakes, the chemical composition of gases venting from the soil, every piece of data is fed into their models, searching for any deviation from the norm. Their job is not to stop the eruption. That is impossible. Their job is to provide a warning. But what does a warning even mean in the face of a cataclysm? If the YVO announced tomorrow that they believed an eruption was likely within the next year, what would happen? The evacuation of millions of people from a dozen states. The collapse of the U.S. economy, global panic. There is no contingency plan for an event of this magnitude. There is no shelter that can withstand a pyroclastic flow. There is no way to protect a continent's food supply from a blanket of ash. We can monitor. We can watch. We can understand the danger with incredible precision. We just can't do anything about it. It's a strange kind of powerlessness. To have the scientific knowledge to foresee a potential apocalypse, but to have no technological means to avert it. We come back to Jackson. The town sits there, a jewel in the wilderness, its residents buying and selling real estate, debating local politics, living their lives under a sky that looks peaceful. But that peace is an illusion. It is a temporary state, granted by geologic forces that operate on a timescale so vast it makes human history look like a flicker. The danger is not that Yellowstone is overdue. The danger is that the system is active, the hydrothermal explosions are real, the tectonic faults are loaded, and the magma chamber below is a confirmed, simmering body of partially molten rock, larger than anyone had previously dared to calculate. We are safe, for now. The 16 to 20% melt is not the 35 to 50% threshold. The ground is sinking, not swelling. The earthquakes are background noise, not a rising crescendo. The monster is sleeping. But the problem with sleeping monsters is that eventually they wake up, and that awakening doesn't need to be a full-blown supereruption to be a disaster. A large lava flow, like the ones that have happened every few tens of thousands of years, would be devastating enough. The most recent magmatic activity at Yellowstone wasn't a supereruption, but a lava flow just 70,000 years ago. A mere blink in geologic time. An event like that today would pave over huge swaths of the national park, send toxic gases into the air for months, and cripple the regional economy for a generation. It wouldn't end the world, but it would end Yellowstone as we know it. This is the spectrum of risk that makes this place so unique. It's not one single threat, but a whole family of them, from the small, sudden steam blasts to the continent sterilizing supereruption. They are all products of the same engine, the same inexorable heat rising from the Earth's mantle. The irony is that the same geologic power that threatens to destroy this landscape is also what created it. The geysers, the hot springs, the stunning volcanic geography, it is all a manifestation of the heat below. The beauty and the terror come from the same source. You cannot have one without the other. Okay, I know this is the third time, and I promise it's the last. But if you've made it this far into the documentary, you're not just a casual viewer. You are someone who craves this knowledge. Make sure you're subscribed, because the rabbit holes we're going down next are even deeper. It's the only way you'll know when we drop the next one. Thanks for your patience with my nagging. So the people in Jackson, Wyoming, are not just living near a national park. They are cohabiting with one of the most powerful and volatile geologic systems on the planet. Their property values are some of the highest in the country, but their geologic insurance policy is non-existent. The facade of safety is built on probability, the low, but never zero, chance that the really bad day won't come in our lifetime, or our children's lifetime. We have built our world on a thin, fragile crust, and we forget what lies beneath. Yellowstone is the place that never lets you forget for long. The June 2026 fissure is a tiny crack in that facade. A small, violent reminder of the plumbing that connects the surface world to the inferno below. It is a message, written in steam and shattered rock. A message that says the ground beneath our feet is not as solid as it looks, and that no one, no matter how wealthy or how far away they think they are, can ever truly outrun the power that is waiting underneath. The clock is not ticking on a 730,000-year cycle. It is ticking